Welcome to the deep dive. Today, we're really diving into a huge global challenge, water scarcity.
It's definitely front and center these days.
Yeah, and it's not just about having enough clean water, right? It's also the incredible amount of energy needed to treat it, move it around.
Exactly. That water energy nexus is critical.
It really is. It affects, well, pretty much everything. How we build cities, how we live day to day. So our mission today is to unpack how the very latest green building standards are tackling this. We're talking DDV5.
The newest version.
And specifically, we want to uncover the strategies, the sort of cutting-edge stuff that lets buildings save massive amounts of water, way beyond just, basic efficiency. If you're as fascinated by these kinds of solutions as we are and how they're changing things, definitely hit subscribe so you don't miss our future deep dives into understanding this world.
Yeah, and specifically today, we're zooming in on LEED plus CV5. That's the building design and construction standard for new projects.
Yeah.
And within that, the water efficiency credit WEc2, which is called enhanced water efficiency.
Enhanced. So going above and beyond.
That's the idea precisely. It's really pushing projects past standard measures towards much more advanced conservation thinking.
And believe me, we're going to get into some really insightful stuff here, like how projects can actually earn up to 8 LED points just from this one credit.
Which is substantial. Given the whole system goes up to 110 points, 8 is a big chunk.
A very big
Yeah.
chunk. And we'll explore the really innovative ways they achieve that. Okay, so let's start with the basics. Why this WEc2 credit? What's the bigger picture here? Why is it so important right now?
Well, the core reason, the intent behind WEc2 is actually multifaceted. It reflects how tied together our resources are.
Okay.
So fundamentally, it's about drastically cutting down how much potable water we use, our fresh drinking water supply.
Right, the precious stuff.
Exactly. But the impact, the ripple effect goes way beyond that. When you use less water, you automatically use less energy.
Ah, the energy connection again.
Precisely. Think about all the energy it takes to pump water, treat it, heat it sometimes, deliver it, and then treat the wastewater afterwards.
Mm-hmm.
Less water used means less energy consumed, and that directly lowers a building's carbon emissions.
That makes sense.
And another big push is encouraging the use of alternative water sources, getting away from just relying on the municipal tap.
Like rainwater, gray water.
Exactly. Capturing rainwater, recycling gray water from sinks or showers right there on site. What's really fascinating here, I think, is how this credit demands a truly integrated approach.
Integrated?
Yeah, forward thinking. It's not just about installing efficient toilets, though that's part of it. It's about a whole system, a strategy for how water moves through and is reused within the building.
So it changes the building's whole relationship with water, essentially.
It really does. It pushes for a fundamental rethink.
That water energy link is so often missed, isn't it? People think about saving water at the tap, but not the whole chain behind it.
Absolutely. It's a hidden energy cost for many.
Okay, so we get the why, the critical need. Now let's get into the how. How do projects actually earn these points? You mentioned a comprehensive approach.
Right. So the main way, especially for buildings aiming for top performance, is option 1, whole project water use.
Whole project. Sounds big.
It is comprehensive, but it's also flexible. It lets projects earn anywhere from 1 point all the way up to 8 points, depending on how much water they save overall.
Okay, how does that work in practice?
Well, it starts with setting up a detailed water use baseline. This means calculating all the water the building would normally consume.
Everything.
Pretty much. Indoor stuff like toilets, sinks, showers, outdoor water for irrigation, appliances like dishwashers or laundry, and any process water, think cooling towers, labs, maybe industrial uses.
Got it. A full picture of standard use.
Exactly. Then once you have that baseline, the project team designs their building and creates a proposed water use model. This model shows the reductions they expect to achieve using various strategies.
And the points come from the difference.
Precisely. Points are awarded based on the percentage reduction in total potable water use compared to that baseline. The bigger the reduction percentage, the more points you get, up to that maximum of 8.
Ah.
And the real benefit of this whole project modeling, it gives the design team enormous flexibility and control. They can mix and match strategies, find synergies, optimize the entire design for really ambitious water saving.
Rather than just ticking off individual items.
Exactly. It encourages genuine, integrated innovation, not just meeting minimums for separate parts.
That sounds powerful for design teams who really want to push the envelope. But what if that whole project modeling approach isn't the right fit, maybe for a smaller project, or one focusing on specific upgrades? Are there other ways?
Oh, absolutely. LED V5 anticipates that. For projects maybe needing a more targeted or modular approach, there are options 2 through 6.
Okay.
These focus on specific reduction strategies. Teams can implement one or several of these, and the points add up. You can still reach the maximum of 8 points this way. It just provides an alternative path to option 1.
So you can sort of build up your points through different actions. What kinds of actions are we talking about?
A real range of practical things. For example, fixture and fitting upgrades. This is pretty common.
Like low-flow toilet.
Exactly. Installing ultra low flow toilets, urinals, faucets, shower heads, things that meet or ideally significantly beat the EPA's water sense standards.
Okay, makes sense. What else?
Then there's irrigation system efficiency, big one for many projects. This could mean using smart irrigation controllers that adjust based on weather data.
Instead of just a dumb timer.
Right. Or using drip irrigation instead of sprinklers, which is much more targeted. Or even just smart landscape design using native plants that don't need much water in the first place.
Drought-tolerant landscaping, yeah.
Then you have process water optimization. This gets into things like industrial processes, making cooling towers super efficient so they lose less water to evaporation, maybe capturing waste heat to reduce water needs elsewhere.
More technical stuff.
A bit more, yeah. And then a really key one we should talk more about, the use of alternative water sources.
Okay, we'll circle back to that. Any others?
And finally, there's a category for innovative water conservation measures. This is for more cutting-edge solutions, maybe closed-loop systems where water just keeps recycling within a specific process, or even treating wastewater right on site for reuse.
Wow, okay, so quite a few different levers to pull there.
Definitely. It allows teams to tailor their strategy.
You highlighted alternative water sources as being particularly impactful. That sounds like where projects can really make huge gains, maybe get those higher point totals.
Absolutely. This is often where projects achieve, maximum efficiency and earn the most points under WEc2. It's about seriously reducing reliance on potable water, especially for things that don't need drinking quality water.
Like flushing toilets or watering plants.
Exactly. So projects implement systems to capture and reuse water available right there on site.
Give us some examples. What are we seeing?
Well, rainwater harvesting is a big one. You collect rainwater from roofs, store it.
And use it for?
Irrigation is common, obviously, but it can also be treated and used for toilet flushing or even to supply makeup water for cooling towers, which can use a surprising amount. It's essentially free water falling from the sky.
Makes sense to capture it.
Then there's gray water recycling. This is collecting water from, say, bathroom sinks, showers, maybe laundry.
Not toilet water, though.
No, definitely not black water, just the lightly used gray water. You treat it on site to a certain standard and then reuse it. Again, commonly for irrigation or toilet flushing. Imagine a hotel reusing shower water for toilets. Huge saving.
Yeah, you can see how that adds up.
We also see condensate capture. HVAC systems, air conditioners, they pull moisture out of the air, right?
Yeah, they drip water.
A lot of water sometimes, and it's very clean, almost distilled. So you can collect that condensate and use it, often for cooling tower makeup water, cutting down on municipal water use there.
Clever, using a waste stream.
Exactly. And then you get into the more advanced stuff, like full on-site wastewater treatment systems. These can treat a building's wastewater to a level where it's safe for reuse in irrigation or toilets. It basically creates a partial closed loop for non-potable water.
Really moving towards self-sufficiency.
That's the key idea. If we connect this back to the bigger picture, using these alternative sources isn't just about points or even just saving water day to day. It's about creating buildings that are genuinely more self-sufficient, more resilient.
Less dependent on potentially stressed external systems.
Precisely.
Yeah.
Especially important with climate change and potential droughts.
It's really quite remarkable thinking of buildings as these mini, highly efficient water ecosystems.
Yeah.
But, okay, having the cool tech is one thing. Making it actually work reliably over the long haul, that's another challenge.
It absolutely is.
So let's talk practicalities. What are the key things projects need to do to make sure these advanced water strategies are truly successful? Not just on the blueprints, but for the life of the building.
That's crucial. Success really depends on a few key practices, and ideally they start right at the beginning of a project.
Like what?
First, and this is maybe the most important, comprehensive water use modeling early in the design. It can't be an afterthought.
So figuring out the water strategy from day one.
Yes. It needs to inform the basic design, plumbing layouts, landscape choices, everything. You build the water strategy into the design, not tack it on later.
Okay, start early. What else?
Second, closely related, is integrated design.
We hear that term a lot in green building. What does it mean here?
It means getting all the key players in a room together from the very beginning. Architects, landscape architects, the mechanical and plumbing engineers, the sustainability consultants, everyone.
Breaking down the silos?
Exactly. When they collaborate early, they spot opportunities. The engineer might know how much condensate the HVAC will produce, and the landscape architect can then plan to use it. That doesn't happen if they work separately.
Makes sense.
Yeah.
Synergies.
Third, and it sounds simple, but it's vital, choose high-performance plumbing fixtures. And I mean really high performance, going well beyond just basic code or even baseline LED requirements.
Investing in the best tech there.
Yes. Top-tier water sense fixtures, ultra-low flow. The savings accumulate significantly over years, almost effortlessly once they're installed. Fourth, you absolutely need metering and monitoring systems.
You can't manage what you don't measure.
Precisely. You need to track water use in real time, maybe sub-meter different uses. This lets building managers see if things are working as designed, spot leaks quickly, identify inefficiencies, and just generally keep performance high. It's about continuous improvement.
Data-driven operation.
And one last key practice, often overlooked, collaborate early with local regulators.
Oh, the rules and regulations.
Yeah. Different cities or regions have different rules, maybe restrictions, maybe even incentives for things like gray water reuse or rainwater harvesting. Understanding those early save massive headaches later helps with permitting and might even unlock new possibilities.
Good point. Navigating the local context.
And thinking about these implementation steps, it does raise an important question, how do we ensure these innovative, sometimes complex systems are not just designed and built well, but are actually managed effectively over the long term? What are some common hurdles?
That's a critical follow-up question for another time, perhaps. But focusing on implementation, it really underscores that this is about building for the long haul, not just for the opening ceremony. Okay, let's bring this all home for our listeners. Why should someone pursuing a project or someone living or working in these communities really care about this enhanced water efficiency? What are the compelling reasons to go beyond just basic code compliance?
The reasons are really quite powerful, and they go way beyond just getting an LED plaque. First off, significant operational savings.
The bottom line.
Absolutely. Drastically cutting potable water use means lower water bills. And as we've discussed, it also means lower energy bills because you're pumping, treating, and heating less water. These savings continue year after year, improving the building's financial viability.
Money talks. What else?
Second, a huge improved environmental impact. Using less water takes pressure off local rivers, aquifers, and reservoirs, which is crucial in water-stressed areas. It also reduces the burden on municipal water and wastewater treatment plants, which themselves use a lot of energy and resources.
So it benefits the whole community and ecosystem.
Definitely. Third, it's about demonstrable leadership in sustainability. Projects that really embrace WEc2 are showing true commitment. This enhances their reputation, helps attract tenants or buyers who value sustainability, and can genuinely increase the building's market value.
Good PR, but also real value.
Right. And finally, perhaps the most critical benefit looking forward, reduced vulnerability to future water shortages.
Future-proofing.
Exactly. By using alternative sources and being super efficient, a building becomes more resilient. It's less exposed to potential droughts, mandatory water restrictions, or inevitable increases in water prices. It safeguards the building's operation and long-term value against climate uncertainty.
That seems incredibly important now.
It really is. It means, like you said earlier, every drop counts. And this comprehensive, enhanced approach genuinely raises the bar for what sustainable building can and, frankly, must achieve.
Every drop counts.
Yeah.
It really does capture it, doesn't it? LED5's WEc2 credit, it's clearly not just about checking boxes. It feels more like a blueprint, really. A blueprint for smarter, more resilient, and ultimately more valuable buildings as we face these big environmental shifts.
Well put. It's a framework for rethinking our relationship with water in the built environment.
So here's a final thought to leave you with. Think about the ripple effect. Imagine if every new building project seriously pursued these enhanced water efficiency standards, integrating rainwater harvesting, gray water reuse, hyper-efficient fixtures right from the start. What kind of massive collective impact could that have on our overall water security, on our energy grids, not just locally but worldwide?
It's a powerful potential impact to consider.
It really is. Thank you so much for joining us on this deep dive today. If you're keen to get exploring how we can build a more sustainable future, one innovation at a time, make sure you subscribe so you can hear more about this world.